Hi, y'all. Welcome back. Today we are going to talk about section 1.4, which is arithmetic sequences and series. Again, this is page 27 of your workbook. So if you have your workbook, we are on page 27. If you do not have your workbook yet, you can print off the notes on the Canvas page, or you can just copy it on another piece of paper. And actually live, we got to start on page 26. Okay, so we're actually starting on page 26. We're going to talk about arithmetic sequences in series today. Okay, so an arithmetic sequence is basically just a list of numbers where you add or subtract the same number every step of the way. So you either add 5, you subtract 5, you add 8, minus 2, whatever it might be, but you do the same thing throughout the entire pattern. Okay. In order for us to do this, there is a formula that we are going to use. Okay, so we're going to use this formula that I'm going to give you. You'll always be given it, so you don't have to memorize it. You probably will by the end of the class, but for right now, AN equals, I'm going to try to do this color coordinated. We'll see. Hopefully I don't mess it up. A1 plus D, and then N minus 1. Okay, so all of those letters represent something different in our problem. Okay, so AN is what we call the last term. That's usually what we're finding. We're usually going to have to find AN. A1, 1 meaning first. That's the first term. So AN and A1. D is what we call the common difference. So common meaning it's the same every single time. It'll never change. So you're always adding 5. You're always adding 7, whatever it might be. Okay? And the last one is N. N is the number of terms. Okay, so that's what all of those things represent. So this very first problem, all we want to do is we want to figure out, is this sequence arithmetic? Okay, and if it is, what is the next term? We're not going to worry about this recursive definition right now. Okay, so is this arithmetic? So to figure out if it is arithmetic, we are going to figure out what's the difference between each term. What's the D value? What's the common difference? So to go from 25 to 20, we subtract 5. To go from 20 to 15, we subtract 5. To go from 15 to 10, we subtract 5. So we are subtracting the same number every single time. Since it's the same number, that means that yes, this is arithmetic. If it would have been like minus 5, minus 5, minus 2, then it would not be arithmetic. Okay? And the last part is, what is the next term in this pattern? So if I continue this pattern once again, if I did 10 minus another 5, so I had a common, I had another blank here, the next term would be positive 5. I don't know why I wrote a negative there. The next term would be positive 5. Okay? So that's the first example. The second example wants us to do the same exact thing. So let's check to see, are we increasing by the same amount? To go from 2 to 4 is 2. 4 to 7 is a difference of 3. 7 to 12 is 5. 12 to 13 is 1. Right? So we're not going by the same amount every single time. Okay, so therefore it is not arithmetic. And so we can't figure out the next term because there's no pattern. Right? I don't know what the pattern is here, so there's nothing that I can do to figure that out. Okay? We are actually going to skip problem number 2. So if you have your notes, you can just go ahead and cross that out. If you are writing it down, just don't worry about that part. We're going to come down here to example 3. Okay, now we are actually going to solve a problem with arithmetic sequences. Okay, and the first thing that we want to do, the first question says write the explicit definition. So Samantha is training for a race. The distances of her training runs form an arithmetic sequence. She runs 1 mile the first day, 2 miles the 7th day. So they tell us right here that it's an arithmetic sequence. So we know right away that we have to use that formula that we just wrote down up here. So we're going to use this formula. Okay? In order to use that formula, I have to know a couple of things. I have to know what AN is. I have to know what A1 is. I have to know what D is. And I have to know what N is. Okay? Whoops, I don't know why I put a question mark there. Okay? So we need to figure out what all of these things are. Now, some of them we'll know by looking at it. Others of them we're going to have to figure out. So let's start. Let's just read through the problem and see what we can find. The distances of her training runs form an arithmetic sequence. She runs 1 mile the first day. So the first day she runs 1 mile. So A1 is 1. She runs 2 miles the 7th day. 2 miles on the 7th day. So that's the last day that we know she ran, right? We don't know if she ran any more yet, right? 2 miles on the 7th day. So my last term in this pattern is 2, right? Because I don't know if she kept going or what. But all I know is right now she ran at least 7 days. And again, she ran 7 days. So that would be the number of days that she ran, and would be 7 in this case. Okay, now what we don't know is what's her difference between all of those days. Like, did she run 1.5 miles the second day? Did she run 1 3/4 miles the second day? What did she do? So we don't know the difference between her days. Okay, so first we need to figure out what that is. We need to figure out what D is in our problem. Okay, so we are going to use that same formula that we wrote down up top on the last problem. And we're going to plug in these 3 numbers. But D, we're just going to have to leave as D because we don't know what it is yet. So if we plugged in all of these numbers, AN is 2, A1 is 1, D we don't know, N is 7. So we have to figure out what that D value is. So we need to solve this thing for D. We need to get D by itself. So based on our order of operations, we always do parentheses first. 7 minus 1 is 6. And then we multiply before we add. So I'm going to multiply 6 and D together, and that would give me 6D. And then this is just a normal problem that you all have done back to your probably 8th grade days. Subtract 1, 1 equals 6D, and then divide by 6. 1/6 equals D. So my D value is 1/6. Okay, so I was able to determine that D is 1/6. Now, the question wants us to write the definition, basically write the equation, okay? So I'm going to plug these numbers back in to get the equation that I need, okay? So the equation that I am looking for, A1 was 1, plus D, we just figured it out, right? It was 1/6. Again, I'm just using this equation, and minus 1. So now this is the formula I could use to solve any other problem. No matter how many days I wanted to find, if I wanted to find the 100th day that she ran, I could figure out how far she ran, okay? So that is the answer to part A. I found the formula that I need. I found the definition. Basically, just find the formula, okay? The next part says on the 19th day, how many miles did she run? How far did she go? Day 19. This is the last day of her training, right? So that is the number of days that she ran, so that's going to be my N. So I'm going to take this 19, put it right in here for N, and solve this thing. 1 plus 1/6, 19 minus 1, and I'm going to solve that. 1 plus 1/6, just like before, parentheses first. 18 times 1/6 is 3, so 1 plus 3. And 1 plus 3 gives me an answer of 4. Okay, I didn't have a ton of room to write it there, so hopefully you can kind of follow along with what I did. So on the 19th day, she ran 4 miles. First day, she ran 1. 7th day, she ran 2. 19th day, she ran 4. Okay, so that is how we use that formula to help us figure out exactly what we need. All right. Okay, now let's go to the next example. We're going to go to example 4. All right, so look at example 4. Now we're going to talk about something a little bit different. Now we're going to talk about what we call a series. Okay, a series is basically take all the numbers of a sequence. So take all of the numbers of a sequence, and we're going to add them all up to find a series. So a series is also a sum. Okay, and we're going to need another formula for this. So this formula is going to look like this. N parentheses A1 plus AN divided by 2. This is how we find the total of that sequence. Okay, so S of N means series or sum. n is still the number of terms, a1 is the first term, an is the last term. So everything's the same. Okay, it's just a different formula, a different setup. All right. So this very first problem, 4a, they told us what a1 is, right? So I don't have to figure that out. They told us it was 3. They also tell us that it has 12 terms. There are 12 items here, so that's going to be our n value. And then they told us that the 12th term is 25. So the last number in this pattern, say it started at 3, and then I went 12 numbers, the last number is going to be 25. So that's an. So they gave us every piece of information that we needed. Right? They told us everything. So we're just going to take these 3 and plug them in here. So S sub n equals n, which is 12, parentheses, a1 is 3, an is 25, divided by 2. And we're just going to solve that. So we start inside the parentheses. So that would be 12 times 28 divided by 2. And again, you don't need to do this by hand. Just put it in your calculator, and you would get an answer of 168 would be our final answer. Okay, so we just typed it in our calculator, and we got an answer of 168. All right, the next one isn't really in word form, right? They didn't give us the series with 12 terms. We have to figure out what they are on our own, okay? So remember, n is the number of terms. So there's 1, 2, 3, 4, 5, 6, 7 terms in this problem, okay? The first term is whatever comes first, 5. The last term is, of course, whatever comes last, 41. So again, I have everything that I need to solve this problem. I'm just going to plug it all in. N was 7, a1 is 5, an is 46, divided by 2. So I just took these 3 numbers and put them in their proper place. So 7, whoops, that should say 41. I got ahead of myself there. Sorry, guys. 7 times 5 plus 41 is 46, divided by 2. And then again, we let our calculator help us out, and we get an answer of 161. Okay, 161. All right, so that is a sum. Sum. Okay, now we're going to talk about a symbol. It's called sigma notation. So you might see this fancy E right here. If any of you have brothers, sisters, cousins, whoever, neighbors, that are in college that might be in a fraternity or sorority, they might have this symbol in their name. This is called sigma. So this fancy looking E is the Greek letter sigma. And it means to sum. It is basically, these 2 problems are basically exactly the same. They're just written differently. Okay? Whenever you see this symbol, we are going to use our calculator. We are going to use Desmos or your graphing calculator in order to solve that, okay? So I'm going to show you exactly what it looks like. So to use Desmos, so I get out of this screen and go here. If you want to use Desmos to do a problem that has sigma, okay, so do a problem with that symbol, you're going to go to Desmos and type in the letters S-U-M, and up will pop that symbol. And then you just type in exactly what you see right there. Okay, now Desmos makes you use the letter N, so just imagine the I was an N. Okay, we don't have to change anything around. So we go to N equals 1. On top is 13, and then it's 3N plus 2, and it tells us right in Desmos what our answer is, 275. Okay, so again, that was type in the letters S-U-M, and that symbol will appear. All right, so I got an answer of 275, and I am done with that problem. Okay, I am finished. Got it right, A plus, easy peasy, right in the calculator. All right. Okay, the last problem we are going to do, the last one that we are going to do is this one. This is the most complicated one. This is the hardest one, okay, because now we're going to have to use both of those equations to get our final answer. So a flight of stairs gets wider as you go down. The top stair has 15. The second stair has 17. The third stair has 19 bricks. What is the total number of bricks used in all 16 stairs? This word right here is extremely important. Total. Whenever you see the word total, that means we are going to have to do a series. We are going to have to use this formula to get our final answer because this is a sum. This is the total. And to use this formula, I have to know these three things. What's n, what's a1, and what's an. Okay, without those, I wouldn't be able to do it. So let's see if we can figure out what they are. N is basically the number of stairs. So in this flight of stairs, what's the total number that we have? We have the first stair, second stair, third stair. And then they tell us right here that all of them are 16 stairs. So that's going to be my n value is 16. Okay, so n is 16. The top stair, the first stair, they told us right in the very first sentence, had 15 bricks. So A1 is going to be 15. The last part is AN. AN, that's how many steps are in the 16th stair, right? Because AN is the last step. And in this case, the last step would be the 16th. They didn't tell us that, right? So we don't know what this is quite yet. So we can't really do this formula yet, which kind of stinks, right? So we have 2/3 of the information we need. But if you remember back to the very first thing we did in this lesson, the very first formula that I showed you was this formula, A1 plus D times N minus 1. If we did this formula, that would allow us to figure out what AN is, right? Because that's what we're going to solve for. And then once we did that, then we could go back and do the other one, okay? So we're going to have to use both in this case because we don't know what AN is. So I'm going to use this formula first. So AN equals A1 was 15. D, again, we haven't talked about D, but I bet we could figure it out. The first step has 15. The second step had 17. The third step had 19. So D, how many are we increasing by to go from 15 to 17 to 19? We are going up 2. So my D value is 2. N, we already know, is 16 minus 1. And now we just solve this thing. 15 plus 2 times 15. 16 minus 1 is 15. 15 plus 2 times 15 is 30. 15 plus 30, 45. So this number I just figured out. I just figured out that AN was 45. Okay? So since AN is 45, now I have all three numbers that I need. I know N, I know A1, and I know AN. So I can do the final step, which is to plug all of this into the formula for the total, for the sum. So that would be 16 times 15 plus 45 all over 2. We would let our calculator help us out here, and we would type it in, and we would get an answer of 480 as my final answer. So in all the steps, all these steps of this flight of stairs, okay, they used 480 bricks to make the whole entire flight. The first step used 15, the second step used 17, the third step used 19, the 16th step used 45, but in total, I took all the bricks and added them, I get 480, okay? So that is our lesson for 1.4. Hopefully it made sense. If it didn't, please don't be afraid to ask. I'll be more than happy to go over it with you some more. That is the part of my job I like. All right, y'all? Peace.